So this video goes along with the activity series organizer, that is page 1205. So take a moment, pause the video if you need to, and pull that page out. So we actually talked about activity series once before when we talked about metallic substances, but we focused mostly on the ability of metals to lose electrons. This activity series that I just want to review really quickly shows you reduction half reactions as opposed to oxidation half reactions. Reduction half reactions are typically the way scientists view things. They don't use oxidation, they use reduction instead. So notice in this activity series that we've completely made up, there are substances that are going to be gaining electrons to become neutral. So these are still metals and metal ions, but instead of looking at how easily will a metal lose its electrons, we're looking at how easily will a cation of a metal gain electrons. So as you can see, we've got various fake elements. And just as a reminder, an activity series shows that the substances at the top most want to undergo that reaction. So the metal ions at the top are the ones that want to become neutral. So they want to gain. So most likely to happen are the ones at the top. Least likely to happen are the ones at the bottom. And if you remember, the way that you look at an activity series is you simply consider where the two substances are with respect to each other. I'm going to zoom in a little bit on this. So if I want to compare Y and Q, for example, Y is the one that wants to be the metal more than Q because Y is at the top. That's the only thing you have to remember. So which one wants to be the metal more? If it's the substance at the top, that's it. That's the important thing to remember. All right, so let's take a look at some examples just to review. Now I feel like I zoomed in a little too much. Okay, so let's consider the reaction between Z2 plus and L. Okay, Z2 plus is the very first guy on the list. L is almost at the bottom. Okay, so Z in this case is higher than L. Since Z is higher than L, Z is the one that wants to be the metal. It's the most likely one reaction to happen. So Z wants to be the metal. L is the substance that more likely will stay as a plus. So now you've got to consider what situation you have. Z2 plus and L are what we have. Well, Z2 plus wants to be the metal. L wants to be the ion. So is this reaction going to take place? Absolutely. It is going to take place. So what's going to happen, and I'm going to zoom out a little bit because again, I made it a little bit too big. So will this reaction take place? Yes, it will, because these two substances are not in their preferred state. Their preferred state is zinc as a cation, or zinc as an element, and L plus as the cation. So another two examples, we've got Q and Y, Q2 plus and Y. So here's Q2 plus, here's Y. Y is at the top, Y is above Q. So Y is the substance that wants to be the metal. Q2 plus wants to stay as Q2 plus. So will a reaction take place? There will be no reaction. So no reaction for this combination. So let's just do a few more just as practice. I've got M2 plus and Z. Okay, M2 plus and Z, very top and very bottom. Z is the substance that wants to be the metal. M is the substance that wants to be the ion. And that's what I have. So no reaction going on here. Okay, X, 3 plus, and L. L and X. X is above L. So X is the one that wants to be the metal. L is the one that wants to be the ion. And look what I have. I have the opposite. So will a reaction take place? You bet it will. So what's going to happen? X is going to become neutral. L is going to become, if you look at the list, just +1. So I've got 3 electrons here. I only got 1 here, so I need 3 of these guys to balance out the electrons from one of the X pluses. So there's my balanced equation. How about M2 plus and Y? Okay, so M2 plus is at the bottom, that wants to stay. Y is at the top, that wants to be the metal. That's what I have. So no reaction there. And then Q and Z2 plus. Z is at the top, it wants to be the metal. Q is at the bottom, it wants to be the ion. It's not what I have. Okay, so I will get a reaction. So Q plus Z2 plus is going to become Z plus Q, and again, look up, it's going to be 2 plus. So I don't have to do anything to balance electrons because they are already balanced. So that's just a review of activity series. In the next video, what we're going to do is we're going to start applying voltages to these half reactions. Each one of these half reactions, because there are electrons moving, has an electron potential, a voltage potential associated with it. So now, instead of just doing this all qualitatively, we're going to move on to do activity series quantitatively, and those are called standard reduction potential series. So that's where we'll go next.